Oh, wait, hold on.
Welcome to this episode of Intellectual Conservatism. Today I'm here with my friend Daniel Vecchio. We were trying to record earlier, but we had tech problems. Everything should be sorted out and good now. Daniel, thank you for being on my show again.
Thank
Obviously,
you.
Daniel has been on the show multiple times, so if you don't know about him at this point, it's your fault. Um, Aside from that, today we're going to talk about the immateriality of the intellect. So Daniel has a presentation ready. This is a paper that you said you admired a lot in grad school, and I saw you post about it on Facebook. And so, can you tell us a little bit about, what was grad school like at the time that you're reading this paper? What inspired you about it? And you can pull up your presentation at the same time.
Okay, sure. Yeah. So I think I mentioned when we were previously discussing this that in college, my grandmother moved in with us and she was suffering from Alzheimer's. And that was really hard for me because, especially for my faith, to watch her slip away, obviously emotionally, but to see that as her brain was attacked, her memories went and her personality changed. And so when I went to grad school, my basic understanding of the philosophy of mind was basically there's physicalism and there's Cartesian dualism. And even though I'm a Catholic and hylomorphism is kind of promoted, it's even suggested in I think it's is in the Fourth Lateran Council, that the soul is the form of the body. I just didn't really understand that until I studied at sort of a graduate school level what the Aristotelian and Thomistic conception of the mind was. So this paper was very influential for me in shaping how I look at the mind. And so I presented it recently to my own students at Victor Valley College. And so let's get into it a little bit here. This is The Immaterial Aspects of Thought by James Ross. A little background on James Ross. He recently passed away in 2010. He taught at the University of Pennsylvania. I believe he had a PhD from Brown and a JD as well. Though I think that was it might have been from the University of Pennsylvania. I have to refresh my memory on that. He wrote on analogy, especially I think the way scholastics use analogy, and other works, Thought and World, which touches on this argument that we're going to be talking about today, and the immaterial aspects of thought, which is the paper we're looking at today. Ross is one of a group of philosophers who are working in neo-Aristotelian metaphysics and philosophy of mind, and really using the toolkit of Aristotle and Thomas Aquinas to approach contemporary questions in science and consciousness. And I think they're making great headway. They're building off of the work of Saul Kripke and others to really make a strong case for a return of Aristotle and Aristotelian categories, especially causal categories. So before we get into the paper, I thought I'd actually bring in this quote from Husserl. Edmund Husserl's typically considered a figure in continental phenomenology. However, he was dealing with a lot of the same issues that Ross was dealing with from an analytic perspective. When Husserl was writing, psychologism was all the rage, and that's the view that you could reduce logic, all things of thought and mind, to really the science of psychology. And so it is a kind of epistemology naturalized that Husserl was dealing with from the sort of continental landscape, whereas Ross is dealing with it on the Anglo-American side much later. But Husserl raises this really interesting thought. He says, let us imagine an ideal person in whom all thinking proceeds as logical laws require. Naturally, the fact that this occurs must have its explanatory ground in certain psychological laws which govern the course of the mental experiences of this being, starting from certain initial collocations. I now ask, would the natural laws and logical laws in this assumed situation be one and the same? Our reaction, I think, to that question since David Hume is that natural laws and logical laws simply aren't the same, that there is no logical necessity in gravity, in force being equal to mass times acceleration, in the various cosmological features, the cosmological constant, so on and so forth. A lot of these things are simply discovered through observation. And this brings me to a second point I wanted to just allude to before we get into this paper, because I think it helps frame the discussion as sort of something to visualize. Here, I pulled two images from a video on YouTube produced by Number Files, in which they used dominoes, simple plastic dominoes, to construct logic gates and ultimately a computer system that could add, supposedly. So the idea here is, on the left, you have a logic gate that I think represents an exclusive OR, where if you push A, D will ultimately fall, or if you push B, D will ultimately, actually, I think if you push B alone, it will do nothing. So this might not be an exclusive OR. I'm looking at it now. So it might be, well, I'll have to think about it. It could be an implication. Anyways, if you push A, D falls. If you push B, nothing happens. If you push A and B, nothing happens. And so you can sort of see how this could be track onto a truth functional logical operator. And basically, they're able to construct a whole system that, if you assign standing domino the value of 0 and a fallen domino the value of 1, you can essentially do binary addition, right? And that was their design. The reason why this is significant, though, is that we know that dominoes don't add. We know that dominoes are essentially inert physical objects. However, when you put a plastic case around a circuit and you shrink it down and make it out of electrical wires and silicon chips and transistors and other things that are mysterious, I think it becomes much more compelling when you hold a calculator in your hand or look at a computer and see all that it can do. And you start to think, gee, this really does reason. It really does think. It's not just an illusion. But dominoes simply follow the laws of nature. They act based on gravity, right? Acting on it. So if we were to take the domino system and put it in outer space, those circuits wouldn't work the same, right? They wouldn't. You push one of those dominoes and it's gonna maybe crash into some of the others, and then they'll all kind of go in all sorts of crazy directions. So it really only works because of the particular case of how gravity on Earth acts on dominoes. And we come to understand that in a predictable way, but it's not really a logic gate in the sense that I'm doing an or an and or an exclusive or an implication in my head. So am I making sense, Swan? I don't know if
Yeah, okay, so this is an example of okay, so going back to the Husserl quote, right?
Yeah.
There's this perfectly rational person, right? And obviously there are some psychological processes going on in this perfectly rational person, and it just so happens, right, that these psychological processes, these natural processes, they kind of almost have a one-to-one correspondence with the laws of logic, such that this person, right, is obeying the laws of logic perfectly. And so Husserl asked the question, would the laws of logic and the laws of nature in this case be one and the same? And then here you're showing that you have like this material setup that we know doesn't do addition, but based on the laws of nature, it can also kind of perfectly follow certain laws, so to speak, of addition, right? And so is the
Mhm.
question here like, oh, does that analogy carry over into this case? Is
Right.
that part of
Is
it?
this,
Mm.
yeah, so the question is, are natural laws and logical laws really one and the same? And the answer seems to be no, they're not the same. Um, when when a physical process is doing what it's doing, we write the law out, it's descriptive of the behavior. Whereas when we explain what a logical law is, if we say what he's doing is modus ponens, that's not just descriptive, right? There's something going on that is normative, in the sense that he ought to be reaching certain conclusions, right? When the dominoes fall, and actually this happens in the video, at one point the circuit doesn't work right because they didn't space the dominoes correctly. But wait a minute, there is no sense in which the dominoes have a sense in which what the correct spacing would be. It's us, because we have an intended result. And so what we're doing is we're tethering, I use the word tethering, meaning to these physical processes because we have intended outcomes, but the dominoes don't, right? And I think that's an important distinction. So we'll get into that, I think, see how this applies to Ross's argument in a second. But yeah, the idea with the Husserl quote is, it would seem that the natural laws and the logical laws would have to be one and the same in this ideal person, if what? If their mental processes are simply psychological or physical in nature. Okay, let's get into the paper itself. I kind of broke it down a little bit by the section of Ross's paper to kind of explain what he's doing. So at the outset, Ross tells us that animal cognition, desire, appetite, and sensory systems have neurobiological explanations that are either resulting from or reducible to physical laws. And in this sense, he's not really challenging, in a more radical sense or Cartesian sense, that all the mental has to be reducible to some immaterial substance. He grants that a lot of these systems that we share with other animals are reducible to or emerge from physical laws. And he calls this the modest project of epistemology naturalized, a term I think can be traced to Quine, which basically means a sort of get out of the armchair philosopher and go out and make observations and talk to scientists. Let's do some science and look at the way the physical world is. The result of epistemology naturalized is a kind of, I think, physicalistic way of understanding the mind, because you're not doing this Cartesian thought experiment of retreating into meditations and considering a priori arguments like the ontological argument. Instead, you're looking at what the neuroscientists say, right? And um, and to a certain degree, he says, yeah, you can make some headway here. I think this would track onto what David Chalmers would call the easy problem. There are a lot of easy problems when it comes to consciousness or the mind that we can explain through physical processes. But there's also this, what Ross will call the Boulder Project, which kind of tracks onto the harder problem. And this is when we apply epistemology naturalized to human thought. And in particular, when we're considering human thought that carries truth values and has formal features. So there's a sort of constellation of issues that are, I think, part of the hard problem. And Ross's paper picks up on one of them. We could talk about these others, but briefly stated, probably the most well-known hard problem is conscious experience, or qualia, the sort of what it's like to experience red that isn't reducible to physical description. You see that with Mary's Room, Frank Jackson's thought experiment. Problems around intentionality or aboutness. That is, that thoughts are about other things, whereas it seems that physical things are not, at least not inherently, maybe in a derivative sense can be about other things, but only if a mind makes it about other things, like dominoes are about logic gates and things like that. And then there's this issue of rationality, which is the problem of formally determinate thought, which we'll get into today. Other issues that might be a part of the hard problem, or at least for me are a part of the hard problem, center around identity and individuation. How do we have personal identity over time? How are we individuated as a self? And where does sort of our what are our criteria for individuation? Physicalism doesn't really provide the tools, I think, for solving those problems. I think they're kind of intractable. There's also the interaction problem that you have both on the Cartesian side. How does an immaterial mind interact with a physical body? But this is also a problem that arises in epiphenomenalism, which could be a form of physicalism, in which you have thought processes that are not really interacting with physical processes at all. So you might think that your thoughts are having effect on one another, but it's really an underlying physical process that's going on. So it's not that my thinking P is true that makes me reach Q because P implies Q. It's some neurochemical response. And then I think there's also this problem that we see in the philosophy of mind of what we might call black box explanations. That is, appeals to words that I think stand in for real, genuine explanations, like appeal to supervenience or to emergence as a kind of placeholder for a real fleshed out explanation for what's going on. And so to me, when I hear, oh, well, that process emerges in a non-reductive way, I'm like, well, I want to know more about what that means and exactly what's going on. It's sort of like, this happens, then there's an emergence, and then you get consciousness somehow from a physical process. So those are some issues, but more specifically, we're dealing with this rationality problem. And the examples that Ross uses are conjunction, modus ponens, and adding. So I guess we should talk about what those are. Those are basically mathematical and logical thought processes. Conjunction's one of the most simple, right? It's basically, if you have a true statement P and a true statement Q, you can join them together, P and Q, and it remains true. Whereas if any one of those, if P or Q are false, then conjoining them leads to a false statement. Modus ponens is one of the most simple deductive syllogisms. If P, then Q, P, therefore Q. And of course, we're all familiar with adding. 1 + 1 = 2, 2 + 3 = 5, so on and so forth. In principle, such truth-carrying thoughts cannot be wholly physical, he says, though they might have a physical medium, because they have features that no physical thing or process can have at all. So what is that? That thing that they have that no physical process can have at all? And that is this formally determinate, truth-preserving quality. So his overall argument can be put this way. It's a simple syllogism. No wholly physical processes are such that they can be determinate, formally determinate. Some thoughts are processes that can be determinate, so some thoughts are not wholly physical processes. So that follows from premise 1 and 2, through Festino, which, if you know your Aristotelian categorical syllogisms, that's the medieval name. This is a EIO2 for my logic students. And so it's a valid argument. And actually, it's kind of interesting because if you think about it, if you follow the logic of this argument, the argument itself is an instance of the very thing we're talking about, right? Festino is a formally determinate argument style, such that when you get to the form, which I said EIO2, you cannot substitute in terms such that the premises will be true and the conclusion be false. I always offer my logic students, and I did actually this semester, this cheap sort of extra credit. I say, if you can find substitution instances for terms such that for Festino or Barbara, you get true premises and a false conclusion, I'll give you an A in the course, no questions asked, right? In other words, if you can show that a valid argument is invalid, then, well, we should co-publish a paper. I mean, this is impressive stuff. You've really done something. So this argument is valid, right? And the questions then, as a philosopher, once you've constructed a valid argument, is to assess the truth of the premises, because, you know, if the premises are both true, the conclusion could not be false. That's the beauty of, or magic of, deduction. So to understand that, then we really have to understand what he means by determinateness of thought processes and why physical processes lack that feature. So he mentions, I can think of in the form that n times n equals n squared, where n is some, you know, natural number. I can think in the form of modus ponens, if P then Q, P therefore Q. This is to reason in necessarily truth-preserving ways, right? What we mean by that is, when I'm doing modus ponens, I can be confident that my deduction is valid. It cannot occasionally fail to be truth-preserving, even rarely, he says. Otherwise, it would not have that form. It would be more like an induction, because what we say in inductive reasoning could be such that the conclusion is only rarely false. So if we compromise on this and say, well, modus ponens works most of the time, then we no longer understand modus ponens to be a valid form of reasoning. We also know, like I said, we can be confident that these processes are truth-preserving in all relevant cases, which is to say that we don't have to run through an infinity of examples, nor even do we have to go through 1,000 examples and then induce that the rest must also be like this. We're confident that it, in principle, is truth-preserving. Without this, there could be no distinction between valid and invalid reasoning, he says. So that's what we really mean by determinate thought processes. These are thought processes. What we're talking about are formal, the form of reasoning. If you've taken a basic logic course, you're familiar with formal and informal fallacies, right? So a formal fallacy is structurally unsound. It structurally doesn't support the conclusion. It doesn't have to do with the content of what is said, but the very logical structure of the propositions and how they work together in a rational process. And that's really interesting, because if we can have these formal thoughts, then it's kind of an instance of the one over the many, right? We know that the many instances of modus ponens all point to this one process. That's what we mean by the form. And likewise with conjunction or adding. So Suan, have I lost you in any way here?
No, and it's kind of funny because if I remember properly, was Ross the one who talked about a quaddition and all that kind of stuff? Or
Right. We'll get to the
yeah,
yeah, the quas,
yeah,
and which will come up when we talk about the indeterminateness of physical processes, right?
is I was just gonna say really quick that I was talking, I mentioned before we started talking that I had a friend of mine who was an atheist scientist and he became Catholic eventually, and he's been struggling, kind of with the immateriality of the intellect. And I brought up that example, and I was just trying to make sure, like, okay, am I understanding the logic properly? Was I kind of abusing the analogy? And I see here that okay, I was understanding what was going on. So thank you, Daniel.
Well, if I can provide that comfort, yes. So and that's the sort of insight that we have from our first person perspective. I know when I'm adding, I know when I'm doing modus ponens. Now you might say, well, what about your intro to logic students? Some of them don't know what they're doing yet, right? I would say what the issue there, and most of the students will admit this, is really that they're still trying to understand the connection between formal thought processes and the names we give them. So they might be like, well, is modus ponens like this, or is it like doing that? Is it like when I deny the consequent, or is it when I affirm the antecedent, or am I denying the antecedent? And they're not sure how the names connect. Now, names are signs. And so I think that most of the problems then, if this is right, that we see in logic is really this process of induction, of inducing in the students a connection between words and formal processes that already exist in their intellect. I tell the students, you already do logic in your head, but you have to, when you learn logic, uh, you're um, you're calling it out by name. You're identifying it. You're saying this is what it looks like, and you're abstracting so that you're understanding it on a formal level. Um, okay, so let's move on. We cannot, in theory, process every case, as I was saying. There are instances of modus ponens that we will never happen upon, and which we could never reason about. I could, if you open up a basic logic book, they love to do this. They'll give you an if-then statement that just goes on and on and on. And they'll ask the student, is this an argument or a statement? And since it's very big, they'll want to say it's an argument when it's really just a conditional statement. But you could have a conditional statement where the antecedent is infinitely long, right? And the consequent is infinitely long. And it would just be impossible for us to even utter it in the lifespan of the universe or in our own lifespan, right? So we couldn't do the modus ponens. And so Ross wants to point out that this is a feature of the content rather than the form of the function, that there's just an infinite variety of content there. It's beyond our capacity. And he says that that point is to be taken literally, that the function is wholly present, not by approximation, exemplification, or simulation, but by a realization in the single case. And he really hits on this word realization, which what I take it to mean is it's sort of, I think I would prefer the word actualizing the form. He uses realizing the form in the particular, which is a sort of a very Aristotelian way of putting it. Like, you've got this particular case of modus ponens or conjunction, and it is a real instance of that form, right? So when I'm teaching my logic students, I always tell them, do your best to get away from the content. They'll have a syllogism about the IRS and bank statements and criminal law or something, and they're trying to put it all together, and they're saying, well, I don't know much about the IRS, I don't know much about tax law. And I say, well, it has nothing to do with it. Just get to the form, right? Because we can all do the form. I remember, and this is another great Thomistic philosopher Gavin Kerr talk about how he once understood Stephen Hawking to be making an argument against God's existence in, I forget if it's A Brief History of Time or is it The Grand Design, one of his more popular level books. And the argument went something like this: if the universe has a beginning, then the universe has a cause. But the universe doesn't have a beginning, so the universe doesn't have a cause, right? And Gavin Kerr is a brilliant philosopher, but he's not an astrophysicist, yet he wanted to write a response to this brilliant mind. I mean, people hold Hawking up next to Einstein, right, as one of the brilliant minds of contemporary physics. How dare Kerr be so audacious, right? But he points out quite obviously to any logician that this commits the fallacy of denying the antecedent. And it's sort of this brilliant thing I tell my students: the greatness of learning logic is once you understand the formal processes, you hold the master key to every discipline. And you can now comment on what astrophysicists and zoologists like Richard Dawkins, and what quantum physicists, and what any other discipline, sociologists, psychologists, are saying, because they are confined to constructing their own arguments within logic. And so very simple fallacy there could be pointed out, and you can really develop a lot of important responses about causality and whether or not an eternal universe would still require a transcendent cause. So I think that's really shows the power of formal thinking. Anyways, Ross goes on to say the truth of the whole block is the truth of the units in conjunction, right? P and Q, it equals true, just in case P is true and Q is true. What I do in the single case is what I would conjoin any string of suitable units, even ones too long for me to think of. In other words, you can't process every case in conjunction either. It's just you're formalizing it. Adding is not estimating, unless it's me trying to balance my checkbook, right? But as a formal process, it's not estimating. And interestingly enough, hylomorphicists will say that animals can estimate. In fact, some animals can estimate better than we can, right? We'll look at a jaguar jumping onto its prey, can estimate the distance it has to jump much better than I could, right? Estimating might not be a physical, might not be an immaterial process at all, but adding is. Anyways, the other side of the argument is the indeterminacy of the physical. And here, this is why I think Ross's paper is so fun. He's drawing on Quine, Goodman, and Kripke to make this point. And these are sort of the all-stars of contemporary analytic philosophy, who are by no means necessarily friends of Aristotelian psychology, as we might put it. Although I would say I'm not sure about Kripke. He might actually be a little bit more friendly to that than the other two. No matter what a physical process does, and no matter how many times it does it, it remains indeterminate. That's the claim. That's not a matter of, well, if it does it a lot, right? If the dominoes fall in a certain way, and then you set them up and they fall the same way, and you set them up again and they fall a certain way, that suddenly they become a logic gate, right? They don't become or. Whatever the discriminable features of a physical process may be, there will always be a pair of incompatible predicates, each as empirically adequate as the other, to name a function the exhibited data satisfies. Now, what does that mean? It means that I could watch the dominoes fall 1,000,000 times, and still, when I go to push the dominoes down the next time, I could make many predictions that would be compatible with the outcome. Maybe this time, this domino won't fall to the left, it will fall more to the right. Physical processes are in their very nature causal, and therefore they don't follow with the force of logical necessity. And he makes this allusion to a sort of related issue, which is abstract objects. And he notes that rectangular doors approximate Euclidean rectangularity, which is to say, a rectangular door is not this abstract object. It's a physical manifestation, if you will, or as he says, approximation of the Euclidean ideal. Physical change can simulate, but not realize pure functions, is what he's going to say. They can approximate them, or they can be tethered to them. What's basically happening is I, through my induction, note some nomological necessity, which is really just on a Humean level, constant conjunction with the faith of and the principle of induction that in the future it will behave that way. And then I build a whole computing system around it, and then tether meaning to the various circuits I construct that work according to natural laws. And when the computer malfunctions, I say, oh, it failed to do modus ponens. It failed to add. Well, no, it malfunctioned because some other physical law came in and took over that I wasn't anticipating. The wire was getting frayed because of tension and because of heat from the processing unit, and eventually the system melted down. Well, are you saying that it didn't operate the way it should according to natural laws? No, it still is following natural laws. So the computer on the next calculation might blow up, right? You don't know that it won't. And this is an inductive problem, right? So he brings up the example of quus. So take x quus y if x or y are less than 57, equal 5 otherwise. So I guess the idea here is you do x plus y if they're less than 57, otherwise it equals 5. Right? A machine is indeterminate in every instance, so there is no determinate fact that it's performing a function plus or quus in any case. You couldn't really punch in into your calculator anything to satisfy the skeptical question of what the calculator is really doing. And you might say, well, of course I can if I go past 57, right? But you don't know if there's some number higher where it will function differently, right? And the point that Ross wants to make is really no scrutiny of the physical processes themselves could rule out that in the future they will behave differently, given some number. So he concludes that it realizes no formal function, it only simulates. He calls it realism without reality, and says, like a flight simulator has enough realism for flight training, so such that you're really trained, but you are not really flying. So a calculator has enough realism that you could get to the right sum, but you weren't really adding with the calculator. He appeals to other concepts like Nelson Goodman's GRU, which is an object is GRU if it is observed before January 1st, 2031, say, and is green, or else it's not so observed and is blue. And so grew, like if you look at an object, and say some sort of topaz or something, and you see it's blue, you don't know that at some future point it will turn green and therefore be grew. So you couldn't really analyze the object and say, well, this is blue and not grew. No amount of observations could ever rule that out. You say, well, you passed the date and it's not grew. Yeah, but there might be some similar property for some further date, right? And so you can never really say. Another example is a projection of a curve from a bunch of dots. You could create a bunch of curves, and any choice you make for how the curve should be, there's a competitor, right? There's another, as he puts it, a incompatible predicate, way to describe that curve, right? There's an incompatible way of describing the gem such that it's not blue. There's an incompatible way of describing what the calculator is doing other than adding, right? So those would be the examples that Ross is giving. And you see, so this really raises this problem of induction, right? The problem of induction being that how do we know that the future will continue to behave as the past? And we're sort of locked into our observations. And when we're talking about physical systems, they are inductively known, which is interesting because when I think about my own thought processes, when I'm doing adding or modus ponens, am I knowing it inductively, or am I knowing that I'm doing it sort of immediately? That is, in a non-mediated way, right? Whereas physical processes are always mediated through our sense observations, something like that.
Yeah, I just wanted to say real quick that so yeah, I was going to just kind of summarize from what I understand. So obviously this is building off of the problem of induction, right? And oftentimes, philosophers will talk about how the laws of nature have a nomological regularity, but not strictly
Right.
speaking, it's not a logical regularity, so to speak, where it's, I guess formally determinate, right? But at the same time though, the human intellect, right? If we suppose that it is like this thing that's mostly, or if not entirely, physical or natural, right? It still can access things that are formally determinate, despite the fact that physical processes themselves have a nomological regularity, right? But not
Mhm.
this kind of logical inbuilt necessity, or uh,
Or truth functionality,
sure,
as he
yeah.
puts it.
Hmm.
Yeah.
Hmm.
So we could say that one question, and this is where he's going to go with this,
Hmm.
is we could go either the Gödelian route of saying, therefore, our minds are not like computers because we're able to do things that computers can't do. Gödel has a kind of similar thought when he's like, I can grasp that a truth that a formal system can't, right?
Mm.
And therefore I can know that a formal system like arithmetic is incomplete. Um, Alan Turing, on the other hand, goes the route of saying, well, our minds are basically meat computers. And at the end of the day, if we can grasp these truths, there must be some higher order formal system that we aren't able to understand, right? And so you can sort of go the two routes. You can, and one I think leads to this problem of skepticism, and the other is an escape from it, right? So these are all skeptical problems that are variations on Hume. In some ways, I think they get at a deeper problem than Hume initially raised, but they all come down to this, as you said, can we collapse logical necessity into nomological necessity? And the answer seems to be no, they're distinct. And on the other hand, we are able to exploit nomological necessity in order to simulate logical necessities, right? And we can do so because of our basic faith, if I'll put that word out there, our faith in induction, our faith in the necessity of the physical. But as I said, you can't, you can't make a domino computer on Earth and then take it to outer space and expect it to behave the same way. You can't take your computer and throw it into the ocean and then expect it to do what it's doing. It breaks, right? And now you're saying, well, it's operating based on natural laws. You might say, well, the same is true of the brain, right? You drink a fifth of Jack Daniels and you're not going to be able to maybe add so well, and maybe you're not able to recall things from the past very well. You're not able, your inhibitions. But that is a question. Okay, and here's the question is, you drink the fifth of Jack Daniels, can you add? Can you think of triangularity? Shouldn't it be that the intellect somehow is impervious to physical physical impediments? So we'll have to kind of bracket that question for a moment. I have a couple more slides I just want to get through. So this does raise the question, but what about natural laws? Natural laws are famously idealized into mathematical forms: E equals mc squared, F equals ma, so on and so forth, right? The various Newtonian laws of motion. But if you notice, and you go to something like the Newtonian laws of motion, they are adequate for making inductive predictions, but only to a certain extent, right? There's a problem of applying Newtonian mechanics to predicting the behavior of even a planet like Mercury as it orbits the sun, because general relativity starts to make a mess of things, right? And when you're dealing with objects like the sun that are supermassive and speeds that are very high, near the speed of light, not that Mercury is going that fast, but in the case of other objects, black holes and things of that nature, Newtonian physics goes out the door. So yeah, you can idealize what's going on, but those idealizations are just that. He gives the example of describing a free-falling body as d equals 1/2 gt, and then notes that no object falling on Earth is in a vacuum and under no gravitational attraction to other bodies, right? So that these are just simple formulas that do the job well enough to get you within a few decimal points of reality. But reality is much more complex, right? Doors are much more difficult to describe than to just say, well, it's rectilinear. Really? Every atom is perfectly aligned such that it's a rectangle, and there's no Brownian motion, there's no quantum effects at the atomic level that would mess that up. Beside the edge of a door is a perfect line? I don't think so, right? So that's the problem. So you can't say, well, that natural laws themselves are sort of formal. We formalize them as a way to make predictions, and those formalizations can work very well, but they're still reality, I think, will always outpace our idealizations of them.
Right, like, so the idealizations, they're contingent on, other things in reality or conditions being true, right? And the idealization on, like, the natural laws, those can be wrong. And, they often can be, because maybe we find out something more about reality and then we have to change, I don't know, maybe the starting point, so to speak, as for example, Newtonian physics, and then eventually getting into examples like Mercury. So,
Right.
right. So the natural laws aren't this formally determinate thing, basically.
Right. And even
Mhm.
E equals mc squared, it's been confirmed countless times. We can't say that. In truth, we should say E equals mc squared unless ... and some further condition could arise in the future where equals 5, right? Where E equals mc squared it turns out to be a quest type thing, right? And we don't know what that might be, but that's the skeptical problem, right? That we can't really generalize with induction in a way that precludes future modifications. Okay. There's a section he calls retreat from the people, in which he says maybe we don't really add, but simulate adding just like calculators do. And then he considers what are the costs. Well, we have to deny that what we are doing, what we've always claimed to be able to do. So that's a big cost, right? Philosophers often talk about the cost of holding an idea. So I teach formal logic and I get paid to do that, but I guess I haven't really been doing that. I thought I was doing it, so it's kind of be surprising. So that's sort of a surface level, like, well, that would be very surprising that we're not doing what we thought we could do all along. Then he comes up with, I think, a deeper objection, which is that can we define platonically what we cannot do, right? So in other words, it seems like in order to take this route, you have to say, well, yeah, there's this thing called formally determinate truth-preserving thought processes, and this is what they'd be like, but we can't do that. And it's like, really, it seems like you understood what it would be. And it's sort of like what Wittgenstein says about, thinking the other side of a problem, right? You can sort of, how did you get outside of your own limitations, right? How did you, if you can't think that way, you sure were able to understand it. And it seems almost like a performative contradiction. And the last thing is that we have to abandon the idea that we're doing pure mathematics and formal logic, which means basically we're confined to everything being sort of an induction, a simulation, an approximation, but we never really validly reason, which is similar to the first point, except it's just making explicit that you're abandoning these very important fields of knowledge. And you're saying, well, we actually don't have pure mathematical knowledge. Like Gödel's proof of the incompleteness of mathematics is technically wrong, right? It's technically wrong that first order predicate logic is a sound complete system. You can't say those things anymore because we can't do formal logic. What about mistakes? Can a computer make a mistake? It can operate contrary to our desires. I think I mentioned this. Can I? Yes. I can make a mistake in realizing the form. Or I can realize a different form than I thought I was realizing. Right? And as I said before, the very fact that I can recognize the mistake and say, oh no, all right, I'll give you an example. On the internet, there's a lot of these questions where basically it's testing whether people who graduated from high school over 20 years ago remember PEMDAS. So it'll be like 2 plus 2 times 3, and then what's the answer? And people come up with all sorts of different answers because they don't remember, oh, I have to multiply before I add, or things like that. They're just making a mistake, not in the sense that a wire has overheated in their brain, but they're realizing the wrong form of mathematical operations. If we were to define a different form, a different order, based on the way the symbols appear on the page, and say, oh, well, technically, under this system, you add before you multiply, then they're not doing anything wrong at all. They're just realizing a different form, if that makes sense.
So in other words, like with the dominoes kind of, falling incorrectly, or the computer erring, and then let's say the person erring, we'd say, I mean, like obviously the computer doesn't err in the same way that the person errs, right? Like when the
Right.
computer makes a mistake, it's like, okay, something went wrong in the programming, right? Or some material part was like, I don't know, maybe not functioning properly. Whereas in the case of the human being, it's like, oh, I just it's the thought itself, so to speak, that was kind of misplaced,
Right.
to some extent. And then you can fix that, you can repair it yourself, but it's not like anything materially, I guess, had to go wrong, so to speak. Is that a fair summation?
I think so. I think that's a fair way of putting it.
Mhm.
And so the question that, so I've put this argument to people who are skeptical of the conclusion that Ross reaches, and they say, well, computers are far more reliable than we are, right? So shouldn't we think that they're much better at adding than we are? And the answer is no. It's just that um, we we are much more fallible in realizing forms than computers are in following natural laws, and that we can get better at it. But the very fact that we can recognize our mistakes is actually a huge tell. It goes back to this question of whether we can define platonically what we cannot do. Can we define platonically what we should be doing? Yeah. And so if I fail to realize it, I can understand my mistake. But I don't think a computer, um, when it makes a mistake uh, or an error, it's not like, oh, I should have fired up this chip, or this, the signal should have gone through that transistor. It's not doing that. It's just doing what it does. So he says no real processes of adding is identical with any process that equally well realizes an incompossible function. Consequently, adding is not a physical process or function among physical states either. Right? No real process of adding is identical with any process that equally realizes an incompossible function. Why is that? Because adding is always going to be self-consistent, right? We're not going to have something along that comes down the pike that suddenly you get to a really high number and the function goes to 5, right, with plus. He then kind of, I think, goes for an even stronger conclusion towards the of his paper, where he says all thought is abstract. So he wants to say something like this: all thought is formal and abstract, able to pick out one definite form among incompossibles, right? So I can really think about triangles and not something that picks out triangles and maybe also some squares, right? It's picking out one definite form, but no physical process could do that. So he wants to say that no thought is really a physical process. That's a stronger conclusion to some thoughts are not physical processes. And that's because he says all thought is essentially formal in nature. This is sort of an Aristotelian point, that what is the mind or the intellect, but it's the form of forms. It's pure form. It's able to think formally. And when it does so through abstraction and through understanding essences, is what we're doing in the understanding, the act of understanding, is really formal as well. So if you think about it, we were dealing with reasoning and we were dealing with the understanding. And those are two different acts of the mind, where understanding has to do with abstract formal thought. And so he wants to say that basically all thought processes are immaterial. Does that make sense?
Yeah, it reminds me actually of what James Madden said when I had him on my channel, because what he basically said is like, look, the mind, the intellect can seemingly grasp things that are immaterial forms, or that they aren't material things, like addition is not a material thing, or operations like that. And so Madden made the argument that then there has to be something in me, so to speak, in my intellect, or whatever you want to call it, that is immaterial and can kind of overlap with that reality and make contact with it in that sense. Or else then
Sure.
you just have things that are totally opposites and can't go together, like oil and water, or some, just use that analogy. I think I get what you're saying.
Right. The way I think Aristotle at one point puts it in De Anima is, when material things receive form, they become that in a sort of concrete way, right? So if there is a formal essence to what it is to be a rock, if matter receives that form, say granite, then the atomic structures would be such that it becomes instantiated as concrete granite. Whereas when a geologist is looking at rocks and thinking about rocks and abstracting to the essence and formal nature of rock, the geologist's mind does not become filled with rocks, right? So why is that? Well, it somehow is able to apprehend the essences, the forms of things. And these forms kind of preclude incompossible predicates, right? Whereas, if a physical thing could always admit of something like Gru. Okay. So some last thoughts, and I have a few of these. Some of them I'll kind of leave them to the audience, or maybe to a future video if we have a discussion with someone who is less than convinced of this. Does the argument fallaciously move from epistemic to ontological properties of the physical? So for example, we've talked a lot about induction, which is a way in which we know the world. Maybe it's the case that the way in which we understand physical objects is limited by induction. And so we're always kind of skeptical of it, and we can't really know that it's formal. But maybe it really is formal, and we just don't have the perceptual tools to apprehend the determinate processes that physical things have. Whereas our first person perspective of the mind, because it's sort of an immediate contact with itself, can recognize its own formal processes. And so this is really just an epistemic limitation. And not an ontological one, not a metaphysical reality, as it were. There are a couple of things that could be said about this. First, you could just say, well, therefore physical processes and mental processes have these very distinct epistemological properties. And that might be enough to say that they are therefore not the same. But that would depend, I think, on a very strong principle of the indiscernibility of identicals or something like that, where you're saying, well, they have different properties, so they can't be the same sort of thing. But what I would say, if you were really asking me, Swan, is I think it will depend on the definition of physical, because I think that the definition of physical really draws in epistemological properties, that what it is to be physical is to be knowable through induction, knowable through the scientific method, knowable through the natural sciences, right? So it's a metaphysical commitment that has at its heart epistemological properties of the thing itself. So when you describe something as physical, you are saying that it's in some sense knowable through the physical sciences. Otherwise, I'm not really sure what physical means. And the other thing is, we've been talking a lot about Humean causality and the problem of induction and the difference between logical necessity and nomological necessity. And I think that there is at its heart a metaphysical commitment going on here, that there is a modal distinction going on, that this isn't just an epistemological distinction in modality, that it is a claim about real, natural, physical processes and how they behave. In other words, there is no further fact to be discovered, and that we're just stuck behind a skeptical wall. It's rather, that is the nature of causality. It is such that it is to be known inductively. So those would be a couple of responses to that. Does that make sense?
Yeah, I kind of tuned out on the last part. Could you explain that one last time? Sorry. Mhm.
Oh, sure. Just it actually was building off of the sort of grades of modality you were talking about between logical necessity and nomological necessity, that they really are. This is a metaphysical distinction, and so we can't really collapse them. It's not like some further discovery, or if we had some further perceptual capacity, we could collapse logical and nomological necessity. The second point I wanted to raise: physical objects do not have an inherent formal semantic or syntactical meaning. What we tend to see is that, you look, and I'll ask any physicalist or naturalist, does this rock have any inherent meaning? I mean, a lot of them are internalists when it comes to meaning. So they'll say there's no inherent meaning to the world itself, or there's no universal meaning to things. It's not like the universe itself cares about truth or beauty or goodness. This rock doesn't care about it, doesn't know about it. This rock doesn't mean anything in and of itself. But we could assign a value to it. We could say the rock on the ledge means true and the rock on the floor means false, right? And now it has meaning, but it's derivative. This is similar to derivative intentionality, right? You write a sentence on the board and you say, well, this says the cat is on the mat, right? And so it's a sentence about cats. Maybe it's about your cat, Sebastian, right? So, but it's actually just ink marks on a whiteboard, right? It's not about anything. It in and of itself, not inherently meaningful. It becomes derivative because we've assigned meaning to it. So that I think is a point one can drive against those who say, no, there really are these formal meanings or formal processes in the physical. I would say, no, the only way in which we have anything like that is when we assign such a meaning to it. So we can tether such meaning to physical processes, and through inductively knowing how those physical processes function, we can simulate thought processes. Now, how might this apply to AI? And this is sort of an interesting point, I think, Swan, is most science fiction depict the problem of AI is not their rationality, but their emotions or their ability to grasp morality or something like that, grasp sort of the deeper meaning of life. So it's never the question of whether they can add or follow logical rules, right? The Data is this hyper Vulcan character on Star Trek: The Next Generation that is confined to logic. He's hyper rational. But the interesting thing about Ross's argument is actually no, it's quite the opposite. You could actually simulate, you could simulate rationality, but I think emotions might be much more easily programmed, right? Emotions are just reactions, physical reactions to stimuli. You program anger, maybe when it sees a certain pattern in the world, its circuits heat up and it can sense that, or and that would be an emotional response or something. What does this say about the human mind or person? Well, I think it might suggest that there's some part of us that is immaterial, and if death is the separation of matter and form, as Aristotle suggests, then this immaterial formal aspect of us cannot die in the usual manner, because there's no matter from it which it would be separated. So I think you can move from here to an argument for the immortality of the intellect, because it can't be destroyed, at least in that sense. You might be able to just on the level of separating existence from form, in which case God could annihilate souls, but you couldn't really naturally destroy a mind. And then I did want to end on, I have this quote: "The thing known is in the knower according to the mode of the knower." So if we know these sort of immaterial formal processes, there's a sense in which we ourselves are immaterial and formal, right? So, and we can sort of know ourselves in this sort of way as well.
Yeah, that was Madden's argument, or a close summation of it.
Yeah, that's a sort of principle. You see that in Aquinas and elsewhere. But yeah, I think that there's some power to that. The last point that I wanted to really get in is, I'm going to skip the normativity because I talked about that already, is Aristotle talking about induction and nous. And this is in the Posterior Analytics, where he talks about the nous's ability to induce to generalizations, and it's really his answer to skepticism. And it's interesting because he talks about what nous does, which is the Greek word for mind. When it induces to a generalization, it's sort of a process of abstraction. And it's almost mystical what he says in this very logical book. But what I gather from it is that he goes so far as to say that the intellect is infallible. Actually, I'm going to stop to share and see if I can bring up the quote really quickly, because I think I have it somewhere. Hopefully. So the quote from Aristotle goes like this. Thus, the states neither belong in us in a determinate form nor come about from other states that are more cognitive, but they come about from perception, as in a battle when a rout occurs. If one man makes a stand, another does, and then another, until a position of strength is reached. And the soul is such as to be able to be capable of undergoing this. So he's talking about induction. What we have just said, but not said clearly, let us say again. When one of the undifferentiated things makes a stand, there's a primitive universal in the mind. For though one perceives, the particular perception is of the universal, for example, of man, but not of Callias the man. Again, a stand is made in these until what has no parts and is universal stands. For example, such and such, an animal stands until animal does. And in this, a stand is made in the same way. Thus, it is clear that it is necessary for us to become familiar with the primitives by induction, for perception too instills the universal in this way. Some of the intellectual states by which we grasp truth, some are always true, and some admit of falsehood. For example, opinion and reasoning, whereas understanding and comprehension are always true. And no kind other than comprehension is more precise than understanding, and the principles of demonstration are more familiar, and all understanding involves an account. There will not be understanding except comprehension. There will be comprehension of the principles, both if we inquire from these facts and because demonstration is not a principle of demonstration, so that understanding is not a principle of understanding either. So if we have no other true kind apart from understanding, comprehension will be the principle of understanding. and the principle will be the principle, and understanding as a whole will be similarly related to the whole object. It's a very difficult passage. But what always struck me is he says that there's something infallible about the understanding. And I always thought, well, how could that be? Don't people get math wrong? Don't they? Couldn't I ask someone if a triangle has four sides, and maybe they think, yeah, it does have four sides. Well, no, they're not thinking of a triangle. That's the problem of confusing the word with the term, the word with the mental object. They're thinking of a rectilinear object when they say a triangle has four sides. And so it seems like this intellect is in some sense in touch with truth itself. It's just a sort of a beautiful thought. When I see someone with diminished cognitive abilities, I realize this is a physical problem, but their intellect is in some sense intact, and their intellect is as good as mine. It's just there's a problem relaying it. And so that's something to think about when we think about, people with diminished cognitive capacities, the people who struggle with Alzheimer's, with various syndromes that might slow down their cognitive processes. What's going on there is a physiological thing, but not necessarily an impairment of their intellect itself. And I don't know, there's something beautiful about that to me.
Yeah, it
So,
kind of
sort
also,
of end on that.
well,
Yeah,
it
go
also
ahead.
gets me thinking about too, like how, even somebody who is cognitively impaired, especially as Catholics and just in general the natural law tradition, they're still fully human. Their
Right.
humanity, their moral status, their personhood, if you will, is not contingent on how well the physical process of cognitive comprehension is working in them. There's still something deeper there to who they are, right? And it doesn't go away with just Alzheimer's or whatever cognitive impairment there is.
Right. And that has ethical implications, right? If you're trying to rationally ground your speciesism, right, which some ethicists want to make the case that, hey, look, treating such humans as though they were animals is wrong, right? It would be wrong to experiment on what some ethicists refer to as marginal humans. It would be wrong to consume them. But a lot of us consume animals, and we think medical experimentation might be ethically permissible. So why is that? Well, we're saying that there's actually something above and beyond that humans possess that is not physical. And, I think a lot of ethicists practicing today would say, well, that's a religious argument, and you can't do ethics in the public sphere by appealing to something like the soul. Well, I'm very sorry to tell you that Ross gives us a very powerful reason to assert that humans, in virtue of our ability to understand and reason and judge truth, the three acts of the mind, I should say, understanding, judging, and reasoning, we have capacities that no other animal has. And therefore, we cannot be reduced to purely physical things.